Hi, I wanted to just shoot a quick video to show you progress that's been made on the new Robokit software that I've been working on. I've just compiled it again for testing. As you can see, since the last video, quite a number of changes have happened, most notably in the interface. That's the most immediate change. We now have a nice banner that runs across the top. The send and receive display showing here on 2 lines. However, the whole interface is completely configurable, so I can move any of this around. I can change the banner text. I can also change the text for this send and receive label. I can change the prompt label, and this new block here is a representation of the internal state counters. So what we have going on is, under the surface we have a state counter which can be enabled or disabled. By default it's switched on, so any time an input or an output state is changed, the state counter pertaining to that channel is incremented by 1. Now this is particularly useful at the moment for the input channels, where I might want to wait for a certain number of pulses on an input channel before I reset an output line. I'm going to show you a little bit of how the commands work for manipulating the user interface, and then after that we'll go through how to drive the Robokit currently. So most of the everything on the interface can be addressed directly. So banner, if I want to change something about the banner, let's say I want to change the text. Okay. The status, I've got 2 status lines. I've got in and out. So the out line, which is the one on line 5 here, I can move that if I want to. So let's move that to, let's move it to column 30 on line 4. So let's move that up there. The prompt, again, same syntax. If I want to move it, let's move that to column 1, onto 5. Actually, you know what? I can step back through commands I've typed. So let's say I want to, actually I don't want that on line 5, let's put that on line 6. Messages line, let's move that up. Okay, and then this state counter output line, you know what, let's move that to out the way. Let's move that over here to column 60 and we'll put it on the same line. So you can see I've got complete flexibility. Every single component on here could be moved. The banner text and the received and send text and the prompt text can all be changed. I can hide any of these components. So for example, let's hide the output state counter display. It's gone. The state counter can be internally switched on and off. I can even drive, for example, the number of clicks between the timer service. So by default it's set to 10, but I can set the poll interval to be much later. It's measured in number of ticks, so it's how many times the it's actually timer B that it's associated with. It directly controls how many processor ticks before that piece of code is run. 10 works quite well on an STE. So as you can see, I've got very deep control at runtime on all of this stuff. Controlling the actual Robokit itself, still the same direct commands work, so I can just feed an integer value, for example. I switch that particular line on there, and I can switch it off. Okay, that's great. So that's exactly as it did before. You notice that the input state counters changed, so here it's very useful. So I can send a direct command and I can actually see how many pulses it takes whilst I'm looking at the device itself, to see how many clicks it takes to get from one position to another. It's something that was fundamentally missing in the software that came with the Robokit. So let's reinitialize. So I can initialize one channel, so I can put in the channel number and that gets reinitialized. Let me show the other output. We can see we've got some ticks that have happened on the output stage, so let's reinitialize those. To reinitialize all the channels, I just send the init command with the value of 8 and that will reset everything. Okay, so now I want to do something more interesting, so let's run a command called set. So with the set command, by running set by itself, it works exactly the same way as just sending the value. I can also send it the binary flags for each of the outputs. So for example, if I send but that's channel 8, 7, 6, 5, 4, 3, 2, 1. This should switch on this little light down here. There you go. And you can see all I'm doing is setting the flags as you see it here. So you've got two ways using the set command. You've got two ways of actually setting setting outputs. Okay. Now what I might want to do, for example, is I might want to say I want to set a particular output until I've seen a particular number of pulses on an input channel. So let's reinitialize my input channels again. And now what I'm going to do is I'm going to say set 16 until 1, so this input channel 1 equals 10. Okay, I'll press return. So now it's counting up input 1, and then when that reaches 10 it should stop. Now I might want to say, okay, let's set 8 until, let's do something more interesting. Let's set 2 lines. So I can either send 40, which is 32 plus 8, or if I want to I can set them by setting a flag. So that's 32 and that's 8. Okay. That 1 equals 10. Okay. So now it's both those lines are set, and it will only stop when input line 1 has reached 10. You can see it's still counted input 0. It's reset input 1 to 0 because it reached the desired result, but input 0 is still untouched. So I've got 23 clicks on there. I happen to know already that it takes 35 clicks on input 0 to get my arm right round to the fully 90 degrees. So let's send it another command. It happens to be 8 until line 0 equals 35. So that will send it the rest of the way. And now I can, so you can see how very quickly I'm able to then set, from here it wouldn't be too big a leap to then be able to write a script with set commands that move it into particular positions in a sequence. The next command that I want to implement is the when command. So the when will, this isn't implemented yet, but the command will look a little bit like this. So when input channel 2 equals 1, set some channel until equals 10. So what that will do is that will wait until I've received a change on input line 2, and that will trigger the output channel 8 to fire until I've seen 10 pulses on 10. So you can see then that I can then start to create a fully automated solution which waits until something's happened. For example, it might wait until I've put something in front of this light sensor here before it triggers off a process. Once I've got that command implemented, then I can finish off the scripting engine, which will be pretty easy because most of it is done. It's basically feeding into the command interpreter that I've already written here, and just some file related code to complete before that will work. and then I have a system whereby I can write the script and run it straight in, and have a very fast automated solution, very flexible. So that's where we are. Sorry, it's probably a longer video than I anticipated, but I wanted to show you everything. Thank you.